In science this week, we're going to revise sound waves and lights and shadows, color, how lasers work, how cameras work, how video cameras work, refraction and reflection. Close your eyes and listen to the world. You can recognize almost everything you hear because it has its own distinctive sound. Sounds are unique because they are all made in slightly different ways, but all sounds have one thing in common. They are created when something vibrates, sending waves of energy into our ears. The sound something makes changes if it vibrates quicker or slower. When an object vibrates quickly, we hear high-pitched sounds. Low-pitched sounds come from things that vibrate more slowly. Most vibrating things make a mixture of many different sound waves. Everything makes a unique mixture, and that is why even two people's voices can sound very different. We make music with instruments that vibrate. Our voices are instruments too, singing when air vibrates inside our throats. The sound of a person talking, singing, or playing music is easy to listen to. Our ears pick up the sound and our brains turn them into thoughts and feelings. Machines and engines have moving parts that grind and shake, making noise, sounds we do not want to listen to. Music is made from sound waves of varying pitch arranged in a pleasant way. Noise is simply random sound, often in a single pitch. Sounds travel as waves of vibration. The bigger the wave, the more energy they carry. When they arrive at your ears, louder sounds push harder against your eardrums. From rustling leaves to jet engines screaming past, our ears can measure an amazing range of quiet and loud sounds. Light is the energy that shows us the world. People are daytime animals and we live in a world of bright light and color. Many animals prefer the dark and thrive when the sun goes down. In between light and dark, there's a dusky world filled with shadows. We see things clearly because light bounces off of them and into our eyes. White things reflect most light, while dark things soak up the light and do not reflect much. In the darkness, seeing things is very hard because little light reflects into our eyes. So opaque objects, light cannot pass through. Those are things like a table and a ball and a chair and a toilet paper roll. And then there's shiny objects like a TV and a mirror and a spoon that the light is not absorbed but it bounces off and it reflects straight back at you so you can see yourself in the reflection. And then transparent objects you can see straight through because the light passes through them. People have been telling time using shadows for more than 5,000 years. As the sun sweeps around the sky, it casts shadows on the ground. The shadow of a stick moves clockwise in a circle. At noon, it always points exactly north in countries north of the equator or south in countries south of the equator. Rainbows paint the sky with color, but what exactly is color? Things around us seem colored because they reflect light into our eyes in different ways. The colors we see are made by light waves of different sizes. Recognizing different colors helps our eyes and brains pick out objects to understand the world more clearly. White light is actually a mixture of all the colors. We know this because white light splits into colors when you shine it through a wedge called a prism. Raindrops and pieces of plastic also split white light into colors in the same way. That's why you can see rainbows in rain and in plastic and glass. If you look at these circles of color. You'll see the one has white in the middle. That is when you mix light. All the colors of light mixed together makes white. Red and green mixed together makes yellow. Red and blue mixed together makes magenta, and green and blue makes cayenne. Okay, which is very different from mixing paint or mixing inks. When you mix magenta and yellow, it makes red. When you mix magenta and cayenne, it makes blue. When you mix cayenne and yellow, it makes green. And then there's black in the middle. As you can see, this is much different from mixing paint. Paint we'll learn about later. Or actually, you know, because red and yellow make green, right? Wrong, it makes orange, guys. Anyway, changing colors. Daylight is made from white light. A tomato looks red because it reflects the red part of the white light into our eyes and absorbs the other colors. If you change the color of the light shining on it, you change the light that reflects and absorbs. This makes the tomato look different and strange. White light looks normal. Green light, the tomato absorbs green light so it turns black. The stalk reflects green light, so it still looks green. And then with red light, the tomato reflects red light, and so does the white background. But the green stalk absorbs the red light, so it appears black. Interesting, isn't it? Lasers are light beams that fire out from a tube packed with energized atoms, often used in light shows. Lasers are also the power behind CD and DVD players, computer printers and holograms, which make strangely lifelike images dance before your eyes. Powerful lasers can leap miles into the sky and even slice through metal. How does a laser work? Lasers are concentrated beams of light. A laser works by flashing light into a special tube. As the atoms inside the tube soak up the light energy, they start to give off light themselves and cause other nearby atoms to give off light too. The rays of light all line up inside the tube and shine out in one single concentrated beam. Reflection and mirrors. Mirrors play, throw and catch with light. They catch light from in front of them and throw it back the way it came. Mirrors are made from thin metal sheets inside glass, but many other surfaces reflect light as well. A smooth lake mirrors the sky above it, and you can often see your face in shiny shoes or a polished spoon. When light reflects off a rough surface, the light bounces back irregularly. So if you look at yourself in a very shiny surface but it's bent, then you can see that it's not shining back to you the same way it would in a mirror, because in a mirror the light shines back very straight and perfect almost. Refraction and lenses. Lenses play tricks with light, bending it so it seems to come from a different place. The science behind this magic is called refraction, and it can make things look bigger than they really are. Lenses are the power behind microscopes and telescopes, which bring the world nearer. Working the opposite way, powerful lighthouses lenses can sweep beams of light far into the night. Straight things often look wonky when they stand in water, and refraction is to blame. When light moves from water to air, it changes speed and bends into a new direction. This can make something underwater appear to be in a different place. Spooky, spooky things underwater. We see things because light bounces off of them and into our eyes, where our brains recognize them. Cameras are like artificial eyes. They can record patterns of light as images and store them for us to look at later. They use lenses to make into light from a wide area and focus it in a small recorder. Cameras record light reflecting off of things. They do this using lenses and motion, which focuses the light onto an image sensor, an electronic chip made of light detecting cells. When the lights fall onto the cells, they convert into a pattern of numbers that the camera stores. Have you tried taking a photo in the dark? If your phone doesn't have a flash, the photo will come out black because your phone camera cannot see light like you can. Then there's all these different types of photography, like slow motion. Cameras can take photos of things happening very fast, and then you can see how they happen in slow motion. And then there's a macro camera that takes photos of things that are very, very, very tiny, like these droplets on a leaf. And there's a Schrillian photo, and we can see color lines that can see air moving. And there's a micrograph that you take photos under a microscope. And there's an X-ray photo. We know how X-rays are made, right? And then there's the long exposure, which takes over a very long time, and then you can actually see how the stars in the sky moves, or where the lights move to. Moving pictures. What is it like to be a pirate out at sea, to live in the future, or to rocket into space? Movies use streaks of light to show us these exciting stories. A movie is made from many still photographs that flash in front of our eyes very quickly. Our brains merge them together to make realistic moving pictures. How can you make a car laugh or a panda dance? You cannot film things that do not exist, but you can draw them on a computer screen and use computer software to turn them into moving pictures. This is called computer-generated imagery, CGI. Look at Beauty and the Beast. In the middle photo, you can see that she is with an actual man wearing this weird suit. That weird suit helps the camera focus on where the CGI people need to make the Beast. And then in the movie we don't see the weird CGI suit. No. We see a computer-generated image of the Beast. Isn't that so cool?
That's all, folks.